Good day everyone. In this tutorial we are going to learn to demonstrate multiple linear regression and binary logistic regression, or the two multivariate analysis that we are trying to demonstrate in this tutorial. For multiple linear regression, we are interested in determining whether the dependent variable in the continuous dependent variable is related to several independent variables or more than one independent variable. In this demonstration, we use crime reporting delays as the dependent variable, continuous dependent variable, and the independent variables are the victim's characteristics, offender characteristics, and incident characteristics. For binary logistic regression, we are interested in associating the dependent variable, which is categorical in nature or nominal, to several independent variables. For this demonstration, we use crime lethality as our dependent variable because it is measured as whether the victim was harmed or the victim was not harmed during the robbery incident. And the same with the multiple linear regression analysis, we have the same set of independent variables. Now let's go to JASP and perform the analysis that we have just discussed. So we are now back to JASP. How do we calculate the multiple linear regression? You just go to regression, then click linear regression. So you are presented with this result and with this interface. We have here the list of variables, and here the window for dependent variable, covariates, and factors. Dependent variable is our effect or the dependent variable in our study. But for independent variables, they are classified as either covariates or factors. Factors, these are independent variables that are categorical in nature or nominal in nature. Whereas covariates, they pertain to independent variables that are continuous. So let's start. Our dependent variable is reporting delay. So place it here. Now let's start with the independent variable. Let's start with victim's sex. Victim's sex is not continuous, it is categorical, so we place it under factors. Now let's look at the results section. Let's go directly to the third table, or the second table, by the way, the ANOVA table. This shows that the model, the p-value here, the entire model with one independent variable and one dependent variable is statistically significant. So let's go to the coefficients table. So this is the coefficients table. Coefficients meaning, what is a coefficient? Coefficient is the standard unstandardized coefficient here. For example, for sex, victim's sex, the coefficient is 3.107. So this is the most important component of this table, coefficients table, 3.107. That is positive, which means there's positive relationship between victim's sex and reporting delays. Since sex here is the reference, the one here is male, let's try, the reference is male, or the one here is male. So if the victim is male, the reporting delay is higher compared to when the victim is female. So look at this. Victim sex, male. So if male, so since the relationship is positive 3.107, so if it is male, that is the victim, there is higher reporting delay. Is that association significant, statistically significant? The answer is yes, because if we look at the p-value for the association between victim sex and reporting delay, the p-value is below 0.05, our benchmark. The p-value is 0.02. So we can say that there is significant relationship between victim sex and reporting delay. But since this is multiple linear regression, we can add more variables. We can add another variable or more variables to victim sex. So let's add now victim's age. Victim's age is a continuous variable, so we should place it under covariates. So click victim's age and add it in the covariates section. Now let's go to the coefficients table. Let's look at the victim's age. With the victim's age, the coefficient is 0.027. It is positive. So there is positive relationship between victim's age and reporting delay. However, the question is that relationship statistically significant? The answer is no. Because the p-value for the relationship between victim's age and reporting delay is 0.63. So that is 63%. That is way higher than 0.05, our benchmark. So there's no significant relationship between victim's age and reporting delay. That means, regardless of age, victim, let me rephrase. Reporting delay does not depend on victim's age. Okay. Now let's add more variables. Let's go to victim's status here. Let's place it under covariates because we turn it into an ordinal variable where there is 1, 2, and 3, and there is an order. Let's go. So is there a significant relationship? No, because the p-value is 0.67. So there's no relationship between social status and reporting delay for victims. Now let's go to offender's sex. Let's move it to factors. Is there a significant association between offender's sex and delay of crime reporting or robbery reporting? The answer is no, because the p-value is 0.861. Now let's add more. How about offender social status? Let's add it to factors. There's no relationship again between offender social status and the reporting delay. Let's move it here. Now let's go to another variable. How about number of victim? Let's move it to covariates. There's no relationship again because the p-value is 0.792. Number of offenders. No relationship again. How about location type? Oh, weapon type first. Let's move it to factors. the p-value is 0.110. This means that there's no significant relationship. There's no relationship between weapon use and delay in reporting robbery incidents. For location type, let's use the individual locations minus the residence. So let's click building. Let's add it to factors. The p-value is above 0.05. So there's no significant relationship between building when the robbery was committed in the building and the delay in reporting. So it doesn't matter whether the robbery was committed in the building or outside the building. Now let's go to open space. The p-value is also higher than 0.05. So it does not depend on whether it was committed in open space or not. Let's add street factors. The p-value again is above 0.05. So this means that there's no relationship between street and the reporting delays. So it doesn't matter whether the robbery was committed on the street or not on the street. They have similar levels of reporting delays. How about whether the crime was consummated? Let's add it to factors. So again, there's no significant relationship. So we can see now the complete table with the list of the variables and the coefficients and the p-value. Let's look at review. Let's review the variables. Only victim's sex is significantly related with the delay in reporting. The relationship is positive, which means that if um, if the victim is male, reporting delay is increased compared to when the victim is female. So, or the reverse is if the victim is female, the reporting delay is decreased. So that's the interpretation of the table. So this is the table of coefficient. So you can copy it and paste it in your Word. No need to copy and paste the ANOVA table. You may just write it in the paragraph that the F degrees of freedom, F, and the p-value. For model 1 here, the model 1 is the R2 and adjusted R2, they represent the variance of the dependent variable that is explained by the independent variables, which means that the percentage of the independent variable that is explained by the independent variable. No need to place it in the here. You may just write it the R or R squared or adjusted R in the paragraph. So that's our tutorial for multiple linear regression. Now let's go to binary logistic regression, where the dependent variable is binary. Again, here we are interested in determining whether crime lethality as measured, whether the victim was harmed or unharmed, is related or associated with other variables. So we are interested of relating or associating crime lethality with the various independent variables such as victim characteristics, offender characteristics, and incident characteristics. Just like what we did for multiple linear regression. So let's start. Where can we find the binary logistic regression? We return to regression button. Click it. Then look for logistic regression. Now, we have dependent variable, covariates, and factors. Factors for category of variables, independent variables, and covariates for continuous independent variable. So let's move first the dependent variable, whether the victim was harmed or not harmed. Click it here. Then let's start with the various variables. Let's start with victim sex. Place it in factors. Let's look at the p-value. The p-value is 0.225. So there's no significant association between sex and whether the victim was sex of the victim and whether the victim was harmed. So it doesn't matter who is the victim, male or female. The levels of harm is the same. Now let's go to victim's age. Place it in covariates. Does age relate to, or is age associated with victim harm? The answer is no, because the p-value is 0.297. How about victims' social status? Place it here, covariates. The p-value is also about 0.136. So there's no association between social status and crime lethality. Let's add offender's sex. Two factors. There's no association also between offender's sex and lethality. Let's go to offender's age. This is covariates. The p-value is also higher than 0.05. So there's no significant relationship between offender's age and whether the victim was harmed. Offender's social status. Let's move it here. The p-value also is about 0.05. So there's no significant association between offender's social status and crime lethality. How about number of victims? Let's move it to covariates. Let's look at the p-value. The p-value is about 0.05. So there's no significant relationship between number of victims and whether the victim was harmed. Let's go to number of offenders. For number of offenders, the p-value is 0.011, which means that there's a significant relationship between the number of offenders and whether the victim was harmed. Here, the relationship is positive, 0.352, which means that if the number of offenders increases, it is more likely that the victim is harmed. It is logical because if there are more offenders, the victim is likely to be harmed. So that's the interpretation of the positive relationship. Number of offenders increases, then the probability of the victim being harmed increases also, because the p-value is significant, 0.011, below 0.05, our benchmark. Now let's go to weapon use. Let's add it to factors, whether the offender used a weapon or not. Let's go to the p-value. The p-value is below 0.05, which means that there is significant association between weapon use and victim harm. What does this mean? The relationship is positive, which means that if the offender uses a weapon, the victim is likely harmed. Or the reverse. If the offender does not use a weapon during robbery incidents, the victim is not likely to be harmed. So that's the interpretation. How about location type? That's place, building. For building, is not statistically significant. How about open space? Open space is also above 0.05, so there's no significant relationship or association between the variables. How about street? When the robbery was committed on the streets, there's no significant relationship also. The p-value is 0.8. 802. Now let's go to whether the crime is consummated. Let's add it to factors. There's no significant association also because the p-value is 0.714. So we have now a complete table of coefficients for logistic regression of crime lethality. We can see that only number of offenders and weapon use are statistically significant in predicting the risk of harm with regard to robbery. Specifically, number of offenders is positively associated with the likelihood of being harmed, which means that if the number of offenders increases, the risk of being harmed during the robbery increases. So if there are more offenders, there is higher likelihood, higher risk of being harmed. And weapon use is also statistically associated with victim harm. And the relationship is positive, which means that if there is a weapon, the victim is likely harmed, either wounded or killed. So those are the interpretations for logistic regression, and earlier we discussed about multiple linear regression. Thank you very much.